Hello, students. How are you today? And happy Tuesday. Let's get started. Our Do Now prompt is about calm down strategies. I love calm down strategies. Y'all know I keep that bubble wrap in the back of the room in my calm down basket. And, whatever it is you do, we all need a strategy to soothe us, to calm us down, to chill us, because sometimes we just are feeling overwhelmed or angry or over the top. So that's our Do Now. Our objective today will be to use the power rule. That's our new information. And we're going to raise a monomial exponent to another power. And I want to warn you, to caution you to be very careful with parentheses as we do this lesson. Our essential questions are: how does the power rule work with numerical bases? And how does the power rule work with variable bases? Our assignment will be to complete our Do Now. Then we have a work page with 16 problems. We have an exit ticket. And as always, show your work to the teacher. Most important thing. If you don't finish in class, that's okay. Just show me what you've done, and then you can finish the rest for homework. If you finish early, we've got a little mindful arts or mindful games activity you can work on. Then we'll get back to our exit ticket at the end of class. So our Do Now question, as we said, it's about calm down strategies. So we're talking about emotion management. Emotion management strategies are things you do when you need to calm down. Okay, so that's what it's all about. Things you can do when you need to calm down. So, what are some emotion management strategies that you can use at school? So, we're specifically asking about school. I already talked about the bubble wrap. Okay, sometimes I fake scream, I just kind of let out a little yell, but I do it while I'm laughing. So, and that's a big one. Laughter, just laugh it off. But when I'm feeling really upset about something, laughter is not coming easy to me. So, I just go look at pictures of my grandchildren, you know. I know some of you loves the squeezing the bubble wrap is like the most popular one that people tell me about. But there are plenty of things: listening to music, just closing your eyes and breathing, doing a mindful meditation. So many things you can do. So please talk about that right here. So let's get a darker color ready. And let's get into our lesson. So right now, what we're doing is we're raising a power to a power. So it's called a monomial. It's a term, one term, where where you have an exponent and then you have parentheses, and you're raising that exponent. You're raising that whole everything inside the parentheses. You're raising it all to another exponent. So when you do that, what you do is you multiply those exponents. So x to the a, all of that raised to the b power, is going to be x a times b power. So let's see how that works. So the simple example here, we have 8 to the second power being raised to the fifth power. So it would be 8, and it would be 2 times 5, which would be equal to 8 to the 10th power. Okay, and that's going to be a big number. Let's get my calculator out and let's see what that will be. Oh my gosh, okay. Okay, so it looks like it's over 1,073,741,824. These exponents really yield large numbers quickly. Now, number two, you're probably wondering why the extra set of parentheses. And the reason that we do that is because we want to make sure that we um, include the negative sign inside of the first set of parentheses, the inside parentheses. So the way it would work is, let me show you. We have the 6 and we have the 3. We multiply those together and we get 18. So what we have to do is, in this case, keep the parentheses. Okay, and we raise that to the 18th power. Let me write that again so it's a little easier for you to read. We raise that to the 18th power. Okay, so when we were if we were to evaluate that on a calculator, that would be negative 15 in parentheses raised to the 18th power. And I'm going to give that to you in scientific notation. That would be 1.48 times 10 to the 21st power. That's a huge number. Now, if we didn't have those parentheses, what would happen is this 6 would only apply to the 15. And in some cases, that can really change things. So you have to watch out for the parentheses because sometimes they include a negative sign. You also have to watch out, use the parentheses carefully because you want to make sure that you are raising a power to a power. Now here we have a negative 2 times 2. So that would be 4 to the negative 2 times 2 is negative 4. Okay, but we would actually rewrite that as 1 over 4 to the 4th power. Number 4, we have 2 to the 4th power raised to the negative 2 power. So we're going to multiply 4 times negative 2. That would be negative 8. So that would be 2 to the negative 8th power, which we would rewrite as 1 over 2 to the 8th power. Now, in this case, number 5, we have a negative exponent of negative 3 and an exponent of negative 7. So we would multiply negative 3 times negative 7, which would give us a positive 21. And that is our final answer. But in number 6, we have 3 to the 3rd raised to the negative 1 power. That would be 3 to the negative 3rd, or 1 over 3 to the 3rd. Now, the rules are exactly the same with the variable bases. What you want to watch out for, though, is the exponent on the outside. We'll look at number 10 here. The exponent outside the parentheses applies to every letter and every number in the parentheses. But, let me erase that so you can see it a little better. The 2, that is the exponent on the D, only applies to the D. The exponent on the C is an invisible 1. So we can do that one right now. So that would be C, 1 times 4 is 4. D, 2 times 4 is 8. And that's the final answer. So why don't you try 7, 8, 9, 11, and 12, and let's see how you do. So let's see, number 7, we have X, 9 being raised to 3. 9 times 3 is 27. And number 8, we have A. 2 times 7 is 14. So that's A to the 14th power. Number 9, we have K, and this time we have 4 times negative 5. That's going to be negative 20. But we're going to want to rewrite that 1 over K to the 20th power. Now, let's take a look at number 11. We did number 10. Number 11, we've got an exponent of 3 outside the parentheses, and we're going to have to treat the m and the n separately, each with their own exponent. So first m, we have negative 2 times 3, that's negative 6, and n, 8 times 3 is 24. So we cannot have negative exponents in our final answer, so we will rewrite this, and n to the 24th power can go in the numerator, and m to the 6 in the denominator. It's a positive exponent now because it's in the denominator. Okay, number 12. Again, this negative 7 will apply to the negative 4 and to the negative 2. But remember, it's going to make each one of these positive because a negative times a negative yields a positive number. So We have our x. -4 times -7 is a positive 28. And our y, -2 times -7 is a positive 14. And that is our final answer. So now we have examples with coefficients. Coefficient is the number that is in front of the variable. So 3 is a coefficient in number 13. 5 is a coefficient in number 14. 10 is a coefficient in number 15. And 4 is the coefficient in number 16. So 3 with an exponent of 2. We can think of it as this way. 3 with an exponent of 2, x with an exponent of 7 times 2. So 3 with an exponent of 2 is 3 times 3, which is 9. And then we have x, 7 times 2, 14. Okay, number 14, 5 with an exponent of 3, n with an exponent 4 times 3. So that would be 5 times 5 times 5. So 5 times 5 is 25. 25 times 5 is 125. And we have n, 4 times 3, 12. Now, number 15, we have 10 to the second power. That's 10 times 10, which is 100. And we have x, 7 times 2 to the 14th power. And number 16, we have 4 raised to the 4 power. And 4 raised to the 4th power is actually 256. 4 times 4 times 4 times 4. 4 times 4 is 16, times 4 is 64, times 4 is 256. And then we have our w, -7 times 4 is -28. So we're going to have to rewrite that. Let me make a little room. So it will be 256 in the numerator, w to the 28th power in the denominator. And that's our final answer. Let's do our exit ticket, excuse me. And then you have a little fun you can have with the pixel art and with Sudoku, where you have to get the same word in each. There are 9 words. You have to get them in each column and each row. So let's go back up to our exit ticket. To raise a power to a power, you must multiply the exponents. Remember negative exponents. So if we have, right here, if we have 2 to the second power raised to the third power, that would equal 3 times 2 to the 6th power. Okay, if you have something like x to the 12th power, y to the -14th power, you're going to have to write it like this. Let me change my color so you can see better. You're going to put x 12 in the numerator and y 14 in the denominator with a positive exponent. So that's it for today. I hope you're able to pick that up. If you're still not quite sure, make sure to ask questions or go back over a few of them again. Again, remember to go back into your those kind of fun things I have if you finish early. So thank you for your hard work. I appreciate all you do. I'm proud of what you do, and I want you to stay with it. Good job, because with practice, you'll be great.